I'm Jiun Kim, the first author of this paper, Learning Point Cloud Completion Without Complete Point Clouds, a pose-aware approach. We are glad to introduce our research. Point cloud is widely used in the fields of computer vision and robotics. Since obtaining complete point cloud is often difficult, point cloud completion tasks started. Most existing studies require input point cloud and corresponding complete point cloud, which is hard to acquire. To solve this problem, we propose a novel point cloud completion framework that does not use any complete point clouds. Before we go further, I will introduce three key ideas of our study. An incomplete point cloud usually results from self-occlusion occurs when observing an object from a certain viewpoint. Therefore, if we obtain multiple incomplete point clouds of the object from various viewpoints, a union of them would be complete point cloud. Based on them, we formulate the point cloud completion as generating multiple incomplete point clouds using a single input incomplete point cloud and sampled poses. This is overall framework. Input point cloud PI is entered into our network. The pose of input point cloud OI and randomly sampled pose OR is used during training. To ensure our network can reconstruct input point cloud, we use input pose OI to generate PI reconstruction head. We constrain reconstruction loss with input to make PI reconstruction head identical with input. Next, we use randomly sampled pose OR to generate another point cloud which shares same object but different pose. Since we only have input point cloud and each pose, generate PR head cannot be compared. Therefore, PR head is re-entered into our network with input pose to generate PI cycle head. This time, PI cycle head should be identical with PI because input pose is used, so we can constrain them with cycle loss. Also, both feature V and V head should be similar since input point cloud of them shares same object. So we also define shape loss to constrain them. Projection method used in our framework is consisted of two steps. First, we define base region, which is yellow, and compute the feature of the empty nodes by interpolating neighbors. Without loss of generality, any poses can be categorized into one of the three cases shown in this figure. Second, we define the visible region, which is blue, and perform interpolation to get the projected feature. From this process, we can get 2D projected feature from 3D voxel feature. During inference time, we need several sampled poses to generate multiple incomplete point clouds. We used 8 poses to generate incomplete point clouds and integrate them to finally get complete point clouds. However, this method requires total 8 inferences for one input point cloud. To alleviate this issue, we use integrated complete point cloud as supervision for training another completion network. We compare with other studies which utilizes unpaired complete point cloud as supervision. Although we do not use any complete point clouds, we verify that our method shows comparable and in some cases better performances. We also conduct ablation studies. We show effectiveness of each loss term by adding shape loss and cycle loss to baseline. We verify that proposed constraints are all effective in point cloud completion. Next, we examine the effectiveness of the number of poses on the quality of the complete point cloud when inference. Similar to intuition, performance gets better when more poses are used. However, it saturates at certain points, so we use 8 poses for our default setting. We qualitatively compare the point cloud completion results. As shown in dashed boxes, we find that existing studies fail to restore certain details while our method can reconstruct them sharply. From this, our proposed method can achieve substantial completion results. To verify our network can generate incomplete point cloud with desired pose, we conduct additional experiments. With some sampled poses which are shown in first row, we generate incomplete point clouds. If only reconstruction loss is used for training, output incomplete point clouds doesn't follow desired pose. However, with all loss term, output incomplete point clouds are well corresponded to their respective poses. These results support that our framework correctly learns to generate incomplete point clouds according to the given poses. Thank you for listening.